Assalamu alaikum everyone. Welcome back. So we started with fractions and decimals chapter, isn't it? I hope everyone has watched the first video and you have seen the introduction for your fractions, isn't it? In that you had seen all your what do you say, introduction of fractions, type of fractions, isn't it? Okay, so we had seen proper fraction. What is proper fraction? In this, your numerator is less than denominator. Okay, numerator is not heavy in proper fraction. In improper fraction, what happens? Numerator is greater than denominator. ऊपर जो है if it is heavy, okay, और जो है जितना होना चाहिए उससे ज़्यादा अगर आप वो कर देंगे तो ऐड कर देंगे तो it will become improper, imbalance. So that's why you will say improper fraction. Okay, and the third is we had seen your mixed fraction. So mixed fraction is what? You will have the whole number and a fraction. So that kind of fractions you call them as mixed fraction. Remember, all your improper fractions can be represented in mixed fractions. Okay, and these mixed fractions, whenever you convert into a fraction, it is always an improper fraction. For example, I have 3 in 3 1 by 2. So this is nothing but if I convert it into a normal fraction, it is 3 to 6 7. This is 7 by 2. So the 7 by 2 is what? Improper fraction, isn't it? Always remember, all the mixed fractions, they are improper in by nature, you can say. Okay, so and all the improper fractions can be converted into mixed fractions and vice versa. Okay, so now let us understand the pictorial representation of fractions. Okay, how exactly you're going to represent. It's good if you understand the topic and how to represent it. It will become easy for you to understand. Okay, I've took one scenario. Okay, like in this is a case, or you can say a tray actually. Yeah, you consider it as a tray. Okay, so in this tray you can accommodate only 4 bottles like this. Okay, the space, it is something just for only 4 bottles. Okay, so all the 4 bottles can be accommodated like this. All right, so this total, when all the 4 bottles are accommodated in this, so this whole will become 1. That means it is a whole. Okay, 1. Now when the same this thing is just filled up with only 2 bottles, let me take 3 bottles. Okay, so the same case, now I will have only 2 bottles and the rest 2 are empty. Okay, let me take, sorry, 3 bottles. Okay, so 1 is empty. So how do I represent this? So in the denominator you will write how many you have. You can accommodate 1 2 3 4 4 bottles, but the space, only 3 bottles are being placed, 1 2 and 3. So that's why it will become, it is represented in the form of fraction, that is as 3 by 4. All right, so this fraction is 3 by 4 is what? It's a proper fraction, isn't it? Now the case in which you can only accommodate 4 bottles, but I have 5 bottles to be placed. Okay, so my I will, what will happen? Your 4 bottles are accommodated here. Okay, like this, and what will happen? One more bottle, you're trying to place it somewhere up like this. Okay, that means it is overloaded now. So actually your space is what? It is of only 4 bottles. Okay, 1 2 3 4, you can accommodate only 4 bottles in it, but you are trying to accommodate 5 bottles. Okay, 1 2 3 4 and 5. This is one is extra, so I will write this fraction as 5 by 4. Alright, so now what is the solution? I can accommodate this bottle in this case. Now what will be my solution? I can take 2 cases, isn't it? I will take 2 cases. In each case you can accommodate 4, isn't it? So in this all 4 are occupied like this. 1 2 3 4. Okay, 4 I am taking here in one case, and this one bottle which is extra, you cannot put it like this, it will fall down. So you will take one more case and you will put that in the second case. So now this is whole. Okay, I will take it as 1, and this will become a fraction. How is it 1? If you have 4 cases, this thing divisions, okay, cases to accommodate, how many bottles are accommodated? 4. So 4 by 4, it will be 1. So this becomes a whole 1. And in the second case, only one space is filled. So what will be my fraction? Yes, it is 4 will be in the denominator and only one space is occupied. So I will take this as 1. So this total whole together, what is my fraction? It's you will take it as a mixed fraction, 1 whole and a fraction 1 by 4. Okay, the same this one I can represent it like this properly in the form of mixed fraction. Okay, so you want to verify what is this 1 by 4 is. If you convert it into improper fraction, 4 ones 4, 5 by 4. 1 by 4 is nothing but 5 by 4, isn't it? So this is how you represent your any fraction. Okay, so the region used will be in the numerator, and denominator will represent number of the total this thing case is divided into 4. So the parts, the number of divisions it is shown, it will be represented in the denominator. Okay, I hope this is clear for you all. We can practice more about this pictorial representation in our class. Okay, so remember, every time all the improper fractions, okay, can be represented as mixed fractions. Okay, and all the mixed fractions can be converted into improper fraction. Okay, so if you say a mixed fraction, that means it is an improper fraction. It can never be a proper fraction. Remember this. All right. Okay, today now let's see what are your equivalent fractions. Okay, now look at these pictures and first tell me what does this first one represent? I mean, what is the fraction for this? So it is divided into how many? 2 regions, isn't it? So first region is 1, 2 and 3, isn't it? So I will take denominator as what? 3. But the used region is what? Only the shaded one, which is the second one. So one region is used. So I will take this as 1. Isn't it? So this will represent in terms of fraction as 1 by 3. Okay. Now tell me how do you represent this? So in this, See, it is the same size, okay? Same size box as we had seen here, okay? But here it is only divided into three regions, okay? Now, when you come for the second figure, what does it represent? It has how many regions? 1, 2, 3, 4, 5, 6. It is divided into 6 regions, so I will take this as 6. And on the used or shaded parts are only 2 and 5. That is, two parts are shaded. So my fraction will be 2 by 6. Now you should tell me for the third figure. What is my third figure fraction? Yes. How many divisions are there in this box or block? Count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, where should I write? I should write it in denominator. Okay. So how many regions are used or shaded? It is 1 here, 1, 2 and 3, isn't it? 3 regions are shaded. So I have got my all my fractions for all these three figures. Okay. So now tell me, can I write this 2 by 6 as 2 1s as 2, 2 3s as 6. So I can write this as 1 by 3, isn't it? It is again, it is same as this 1 by 3, and this, even this will be equal to 1 by 3, isn't it? So what does this mean? So all these 2 by 6, okay, and 1 by 3 and 3 by 9. 1 by 3 is nothing but it is 2 by 6. That is, if you cancel this, you will get again 1 by 3. This is equal to 3 by 9. So the equivalents of 1 by 3 are 2 by 6, 3 by 9, and again you should get 1 by 3. So 4 by 12. 4 1s as 4, 4 3s as 12. So I will get again 1 by 3. Okay. So you will have so many equivalents. So equivalents of 1 by 2 is what? 2 by 6, 3 by 9, 4 by 12 and so on. Or you can say equivalents of 4 by 12 is 3 by 9, 2 by 6, 1 by 3. Isn't it? So what does this mean? The fractions will have, this is called as a basic or standard form. Okay, so you cannot cut 1 by 3 more, whereas the others you can cut them. Okay, so I can cut this and I can bring it as 3 minus 3 3 is 9. This as first, if you want to cut it by 2, you can do it. So 2 2s as 4, 2 6 as 12, 2 1s as 2, 2 3s as 6. Now further you can't cut this. So the numbers which we can't cut further, okay, like 1 by 3, so this is a standard form. Okay, so whenever problems are given for you in the fractions, that is basic operations, when you do add, subtract, okay, multiply or divide, so of all the fractions, you need to keep that fraction answer in your standard form. Okay, I hope you understood what are equivalent fractions. Alright, so now we need to just see what are your like and unlike fractions. Alright. Okay, so I hope everyone understood equivalent fractions. If you have any doubt, we can discuss, we will do more problems on it in our Zoom meeting. Okay, now let's see what are like fractions and unlike fractions. Okay, if I'm given with the two fractions, 1 by 2 and 1 by 3. Okay, so how do you say that fractions are unlike? You will check your denominators. So you don't have denominators same. Okay, so you call 1 by 2 and 1 by 3 are unlike fractions. Okay, whenever they both are unlike, you will convert them into like fraction. How do you do that? So first of all, like fractions mean you will have a denominator same. Okay, so here denominator is 2 and here also it is 2. So I will say 7 by 2 and 8 by 2 are like fractions. Okay, and similarly if you have something like this. Tell me, is it like fraction? They both are like fractions? Yes, because denominators are equal. So like fractions are what? In like fractions, denominators are equal. Okay, you need to check whenever you do the operations addition and subtraction. You will first check for whether they are like fractions or no. Okay, so unlike fractions means you will have denominators different. Okay, so when you go for problem, I hope you understood what are like fractions and unlike fractions. Okay, so you will convert this unlike fractions into like fractions either by using LCM method. Okay, let me tell you this. So this is unlike fractions. These are unlike fractions because denominators are different. Okay, denominators are different, they are not same. Okay, here denominators are same for like fractions. All right, so first of all, any problem given for your basic operations like addition and subtraction, you will just check whether they are proper. And if you are comparing also, okay, if I say if ask you which fraction is greater, so in this like fractions, it's easy to tell you which fraction is big or which fraction is greater. So out of 7 by 2 and 8 by 2, your 8 by 2 is the bigger fraction. How do you say that? Because denominators are same. Okay, now you will compare your numerators. So 8 is greater than 7. Therefore, your 8 by 2 fraction is greater than 7 by 2. Similarly, when you come for this two fractions, if I compare which one is greater, yes, denominators are same. Okay, now compare your numerators. So your 10 is greater than 5. So my 10 by 7 fraction is greater than 5 by 7. Okay, this is how you compare your fractions. First, denominators you need to check. If they are like, it's easy for you to compare the numerators. Now, what if you have unlike fractions and they have asked us to compare the two numbers? How is it easy for you to compare? No, you cannot compare. You cannot say which fraction is big or which fraction is small. Okay, so what you will do, you will first make your denominators equal. That is, unlike fractions, you will convert into like. How do you convert that? I will do multiply and divide by 2. For 1 by 2 is your original fraction, so I want to make it, how you need to do is you need to check like what if you multiply with 3 and what you multiply with 2, you will get same. Okay, so if I multiply 2 with 3, I will get here 6, okay, in the denominator, and if I multiply with 2, I will get 6 again, isn't it? So I will multiply 1 by 2 with and divide by 1 by 2 with 3. Okay, and for 1 by 3 to make them like, I will just multiply and divide by 2. So here I will get 3 by 6. Okay, and this is 2 by 6. Okay, so your 1 by 2 equivalent is 3 by 6. Okay, so 1 by 3 equivalent is 2 by 6. So now we have got two fractions, equivalence fractions we got, in which your denominators are same. Now it's easy for you to compare, isn't it? So denominators are same. Now compare your numerators. So 3 is greater than 2. So therefore 3 by 6 is greater than 2 by 6. That means 3 by 6 is what? 1 by 2. This is greater than 1 by 3. Okay, this is how you first convert the unlike fractions into like, and then you will do the operations like comparison, addition, subtraction. Alright, I think we will stop here. Assalamu alaikum wa rahmatullah.